Okay, good. Good afternoon, everybody. We are here starting the afternoon session with a very stimulating topic, technology. And the question is, what is missing? So we will discuss for an hour and a half about what is missing, but I would possibly add also another provocative question. Is there anything missing? Or do we have solutions already? And probably problems are elsewhere. So I think that the topic is really kind of stimulating, very complementary to what we have been hearing so far today. In the preparation of this meeting, within the committee, we discussed a lot of problems. We also specifically set up a strong relationship with the Sustainable Development Goals. And also, this is another stimulating reflections, because Sustainable Development Goals could be thought as something that is not close to us, that is 12 years ahead, or 11, that is not really something that touches our lives. But I think we have to rethink or to think at this very important challenge that we have for 2030, and taking also the Sustainable Development Goals as a means for us to find metrics for assessing progresses that we are making in all the different fields that we are exploring these days, and these 2 days in particular here in Budapest. So talking about the SDGs, of course, means talking about SDG 6, which is about water, but think about technology. It's immediately related to innovation. And of course, as we will see, for example, SDG 7 about energy, but also 1 and 2 about poverty and hunger. So it's really quite stimulating exploring water these days from many different viewpoints and converging probably to the analysis of very common problems, but as I said, from different perspectives. So in this session, we have a nice combination of very respected experts from different fields that will contribute through the keynotes and the panel discussion. First of all, I would like to welcome His Excellency, the Honorable Sam Cheptoris, who is the Minister of Water and Environment in Uganda. And nicely, I read also that he has a nice combination of playing a very important political role there, but also having a background in education. And this, I think, is a very important element of that we have also touched several times these days. So how to make what is available really implementable, so how to move towards implementation. And this, of course, touches problems like education and the development of local capacities. I know you are particularly involved in irrigation and in development in your country, so which is actually also in the Nile River. So it's really a very, very important experience that I'm sure you will share with us. After Minister Cheptoris, we will have Johannes Kuhlmann, who comes instead from the World Meteorological Organization. And he's in particular, since 2015, the director of Climate and Water Department, which again opens another window that probably has not been touched so much, at least today, the relationship between water and climate change, or global change more broadly. Johannes has a background in hydrology, and he served both as a researcher, for example, at the Max Planck Institute in Germany. He served national agencies and international agency, and he worked in Latin America, to my knowledge. So I think he has really a lot to say today. After these two keynotes, we will give the floor to the panelists. And first, I will mention Joe Manos, from U.S. Army Corps of Engineers. He's currently director of the Institute of Water Resources there. But also in his case, he has a combined background and experience serving the Corps indeed, but also teaching at George Mason University and the Academy of West Point. So also being very much related to academia with his PhD on civil engineering that he got from the University of Minnesota. And of course, the challenge is to pronounce the Hungarian names. Istvan Kéners, maybe something like that, of Biopoulos. This is also academia and business because from what I know, you have an experience at the Budapest Technology University, but then you moved, or at the same time, you moved to what can be considered possibly a spin-off, or in any case, a business activity. I read in one of your websites that a quotation that I liked very much. You wrote, build useful and very practical things that can help people. This, I think, is a very stimulating statement for us for today, moving from knowing what we need or what we have towards implementation. Then we have Giovanni De Santi from the European Commission. Different background in this case because I know you studied mechanical and nuclear engineering, and you have also a PhD in fluidodynamics. And also in your case, I know you are authors of several reviewed papers, but also you have a long experience at the Joint Research Center of the European Commission, dealing with energy, transports, and environmental sciences. And you are currently the director of the Directorate for Sustainable Resources since 2017. So also in this case, I think you can open a window, and in particular, probably saying something about the nexus between water and other dimensions, and energy in particular. And then, last but not least, I would like to thank Pierre Victoria because he has been here just before lunch, and he contributes also to our session, so I don't need to introduce him because he was keynote before. But I think also that Veolia experience can be very important for us today. So let me just give the floor then to Minister Chaptoris for his speech. I understand that you will have to move very soon, and also in the case of Johannes, you will move before the end of the session. So it's a pity for us, but we understand very well that you have also some other important things to do. So, Minister, the floor is yours. If you want to go at the podium or stay here, as you wish.
Do I cut this?
Oh, you shall have a mic here, if you like, but if you want to sit, that's up to you.
Okay.
Okay, please.
Good afternoon, friends. The title of the presentation is How Can Technology Help End the Global Water Crisis? This is the experience from the developing world. From the developing part of this world in a country called Uganda. Water, as we all know, is one of the most precious resources on this planet. More than 1 billion people do not have access to clean drinking water, and around 3 billion experience water scarcity at least 1 month per year. Water scarcity, both natural and a human origin, is the lack of sufficient available water resources to meet the demands within a region. It is, however, worth noting that the available freshwater resources on Earth are more than enough to meet all our needs. What humankind is currently using is very small compared to the available freshwater resources. The problem, therefore, is that water is not available in adequate quantities and in right quality where and when it is needed. There is therefore a need to adopt smart technologies for saving and treating water more efficiently in order to address the current and looming water scarcity challenges in the world. How can technology help address water scarcity in developing countries? A number of technologies for water management have been developed over the years and are already helping to address water scarcity challenges in the developing world. A lot more, however, needs to be done to promote more innovative technologies in view of the looming water crisis. Some of the examples of how technology is helping address water scarcity are presented below. In terms of domestic use, many parts of the world are facing water scarcity challenges because of inefficient use of water produced by water utilities. Currently, unaccounted for water in many developing countries is as high as 70%. For the case of my country, Uganda, the average unaccounted for water in urban areas is 30%. This is still very high and makes us lose a lot of water that would have otherwise been used to provide safe water to more people. There is therefore a need to reduce the unaccounted for water as a means of addressing water scarcity challenges. Technologies for leak detection are already showing good results and could help in this regard if widely promoted and used. In addition, the use of technologies such as prepaid meters, as well as use of tokens at public standposts, are also helping to improve water use efficiency. If most of the water users had meters, then water use efficiency would greatly be improved. In terms of water use for flushing toilets, a lot still needs to be done. The world over, toilets account for over 30% of household water use, and every flush of a conventional toilet requires about 11 liters of water. At household level, the use of waterless toilets can help reduce water use. In addition, innovative toilet systems that don't require water have been developed and are being used in many countries in Africa, such as Kenya and Uganda. Water purification technologies. Technology for water purification has developed quite fast over the last few years. There are traditional technologies for water purification, such as micro and ultrafiltration and reverse osmosis, that have been used for many years and are fairly well established. This will continue to be useful, especially in developing countries. However, new technologies for water purification continue to be developed. For example, bioreactors have been developed to decontaminate wastewater and are currently being tested in many parts of the world. They are reported to purify water in a few minutes with no chemical input, are scalable, and can be driven by hand, bicycle, or motor. If they prove to be effective, they have a great potential to revolutionize the treatment of wastewater in developing countries and help to address water scarcity challenges. Rainwater harvesting technologies. Rainwater harvesting technologies have been widely practiced for many years. Rainwater is harvested through rooftops, dams, valley tanks, sand dams, percolation pits, check dams, etc. And it is seen as one of the most effective ways of addressing water scarcity in developing countries. Rainwater harvesting technologies therefore need to be widely promoted and scaled up. Water recycling. Innovations in water recycling are becoming widely adopted as a means of addressing water challenges in developing countries. A number of industries in developing countries, such as Uganda, are recycling water, thereby improving water efficiency and also reducing wastewater discharge and hence pollution. Although water recycling has shown great potential, the technologies have not been widely adopted and so need more promotion and scaling up. Use of technologies in agriculture. Over 70% of the available water resources in the world are used in agriculture, and this proportion is slated to increase due to increased focus on irrigated agriculture as a means of adapting to impacts of climate change and also improving food security. Many developing countries, my country included, have always depended on rain for irrigation. We use rain-fed agriculture for food production, but with the increased intensity and the frequency of droughts, they have been forced to move into irrigated agriculture. Considering that agriculture is known to be very inefficient in use of water, technologies for improving water use efficiency, such as drip irrigation, will go a long way in contributing to addressing water scarcity problems. As I mentioned earlier, water is not available in adequate quantities and the right quality where and when it is needed. Some places have too much water, often causing floods, while other areas have too little, resulting in droughts. To address water scarcity challenges, water needs to be moved from where it is in plenty to where it is limited. Thus, technologies for interbasin water transfers and a bulk water supply needs to be given more attention. Groundwater development and use technologies. Groundwater represents one of the largest stock of accessible fresh water and accounts for about 1/3 of freshwater consumption globally. Owing to its relatively stable yield of high-quality water, groundwater has emerged as an extremely important water resource for meeting domestic, industrial, agricultural, and environmental demands. Groundwater has given rise to abundant social and economic benefits because of its minimal infrastructure requirements, ease of access, fairly uniform yield, and a high water quality. Both urban and rural populations in developing countries rely almost entirely on groundwater for their daily domestic needs. Groundwater is used in all kinds of industries, and it also serves as a reliable source of irrigation supply to ensure crop production during times of drought and a shortage of surface water supplies. There is therefore an ongoing silent groundwater development revolution in most of the developing countries, aimed at addressing water scarcity challenges. This revolution requires development of innovative groundwater investigation, development, and pumping technologies to cope with the challenges. Many wells are now being drilled up to very deep depth, and thus innovative borehole seating and drilling technologies are needed in order to locate suitable zones for drilling and also to be able to construct successful boreholes. In addition, many boreholes that had traditionally been fitted with hand pumps are being fitted with solar pumps as a means of addressing the ever-increasing demand for water. Thus, innovative pumping technologies need to be developed, and a number are already being tested in many parts of the world. In conclusion, a number of technologies are already helping address global water crisis in developing countries. More investment is, however, needed in promoting more innovative technologies. While technology is very key in addressing water scarcity challenges, technology alone cannot solve these challenges. Water needs to be better managed, better valued, and better preserved. Combining technology with softer options such as water use efficiency, reuse, recycling, and collecting action programs with stakeholders within a watershed will go a long way in addressing water scarcity problems of the world. Thus, a holistic approach to addressing water scarcity challenges is needed in order to better anticipate and manage water crises. Thank you very much for listening to me.
Thank you, Minister. Thank you a lot for coming and for sharing your views, and also for your last conclusive remarks, which I think were very valuable. Okay, so I think, Johannes, we can ask you to go to the podium and probably move to something more technical about data, if I remember properly our exchanges we had before.
Yeah,
please.
I will give you a little overview, and I will try to operate this here from the podium, about why people are still surprised by floods and droughts. So I had been asked to frame a question around the topic of this session. So my question to you is, why are people still surprised and not prepared when events hit them? This session is also about technology, and maybe before I start, I think there's actually two technologies, if we had them, that would resolve the water thing in one go. And the one technology is a nuclear fusion reactor, which we want to get, but we are still some years away. You can talk to nuclear scientists about that. So that would really resolve the water issue. Free energy for all, forever. And the other technology is a technology that we don't want to have, and that would be population control. So that's a technology that we don't want to have. So two technologies I can think about that would resolve our problem, but none is available at the moment or wanted at the moment. So, okay, I will talk about this, and I hope you can see that. Can we have the slides bigger on the screen, or is that the standard setting? That's the standard, okay. So I will talk about this question. Why is that important? It's also not surprising that within the adaptation priorities of member states to climate change, floods and droughts rank the highest. So this is really the big issue that we have in water-related adaptation to climate change, and we have heard from the ministers. He spoke about food security, and again, drought is probably the main driver. We had this discussion this morning in the Water and Peace panel, and you will have another session on that one too. Droughts are also one of the main drivers for migration and all the related issues we have with that. So why are people still surprised or not prepared? Why are our societies not resilient against floods and droughts? And I will give here a short overview about the status quo. The tools that we have. Overall, WMO members are 193 member states, and of those, only 40% have a well-established, always working national flood forecasting and warning service. So you can think, okay, floods are the main issue in climate change adaptation, but yet we do not even have at the moment a decent coverage for all the people in relation to flood warnings. And the decent coverage is not only that a national agency produces a forecast, the decent coverage is that everybody who is concerned actually gets information on what's happening. This is a little bit more in detail. National riverine forecasting capabilities are 1 to 6 are the WMO regions, 1 is Africa, 2 is Asia, 3 South America, 4 Central and North America, 5 is the Pacific, and 6 is Europe. And you can see we've only got confirmed riverine forecasting systems existent in about 40% of our member states. We have 25% of members where we know they actually don't have any consistent national river forecasting. And then there's also a gray zone where we don't really know if they have it or not, or they can't agree. So this, to me, is an unacceptable fact, and this fact can only be resolved through strengthening operational hydrology. And same holds for members with practical operational drought warning policies that have an implementation arm to their drought warning policy. So it's not about having that on paper, it's if that works for the people or not. And yet again, this number is like 2 or 3 years old, so maybe we're now at 50% of members who have that. But it also means that the other half glass is empty, and this is not a service we should provide in the 21st century to our people. Reasons for why this is so. Reason 1 is, I think, there is not enough access to data. So this, again, is an operational problem. We have a fairly okay meteorological data exchange on this world, but the hydrological data exchange is poor. And this is for a missing national capability again. So only 45% of our members have a quality management control for their hydrological data, which in turn means most of the countries on this planet don't know what quality their hydrological data is. So then imagine how would you negotiate with your neighbor on a water sharing agreement if you do not know exactly what your resource state is. I mean, this cannot work. It cannot work because the people don't have the confidence and information to engage in a meaningful cooperation process on in this regard. There's one very nice initiative that the High-Level Panel for Water has come up with under the guidance of the Australian government in this case, and we are now trying to promote this World Water Data Initiative together with the World Bank and UN Water partners to help member states to get better access to water data and information as a key requirement for all the management or early warning businesses they need to deal with. The other reason, and I am maybe being a bit simplistic here, but the other reason for why we don't have the impact that we would actually wish to have is the limited impact of the services that we provide. And this here is the example of the Idai flood in Mozambique. And now you can probably not see what's on this slide, but the graph is the post-disaster assessment. And it shows all these areas that were impacted. And it's actually not about infrastructure alone. It's really about health, it's about housing, it's about education, culture, fisheries. So the impacts of something like a big event are so diverse in a society that it makes little sense to produce, I don't know, an advance warning that in this case here was there, but the people could not really relate to it. So the recovery cost of this event is 3.2 billion estimated, and that's fine. The world can cope with that. But that 650 people are dead, this is our fault, because the warning was there, but the people didn't know what to do with the warning. So we really need to change the way that we transport actionable information into all the different sectors of society about what a flood event might mean, or a drought event in that case too. And we can only do that, I think, if we integrate hydrological value chains, where a hydrological value chain is really from the monitoring, through the modeling, through the decision support. And this here is a graph that's based on WMO activities, but it really holds for all the different actors that are related to floods and drought events. And I think we have made some good progress in the last years about defining the matrix of all the different actors that need to play together to provide this value chain for all the different people that need to be provided with. But yet we lack the coordination amongst UN agencies, amongst member states, to really step up in this. And this is a political issue. This is not a science and technology issue. I believe that science and technology for delivering hydrological services for floods and droughts, we have that. We don't need more complex things or new things. We need to think about how do we make what we have work. And I'll give you an imperfect example of what I mean. This is the WMO flood forecasting, flash flood forecasting and guidance system. So this was established based on our Congress. So member states have asked us, please give members a tool to help them being prepared for flash floods. And I can now tell the success story. I can say we have 2 billion people covered and we have more than 200 trained forecasters. But the flip side of this coin is also that we don't know how many people actually get this warning. So we have produced a tool that is imperfect in that we don't really know how the last mile is covered. So we need to really involve the people in the design of these things and make sure that we get a system that we develop systems that stem from the demand and not from, I don't know, the scientific possibility or the technological capability that we have. I think we always talk about the best data or the best model, but that's not what we need. We need the appropriate data and the appropriate model to cover most of the information that people need to survive hydrological extreme situations. I have 3 slides now with what's next and some key issues and take-home messages. So I think what's next, we need to recognize that there is a gap between the technical capabilities we have and the low-tech operations that we have in most of the countries on this planet. So most of the countries are not up to speed in terms of operating a totally integrated earth science model and to derive all the services we need to derive from that model. But most of the countries struggle with data, with monitoring, with data handling, and we need to acknowledge that and provide technical solutions to gear up the operations that people need to do, first of all, to know what they have and to know how they can, with what they have, meet the demand or safeguard their populations. We must finally stop talking about the last mile problem. I think I'm working in the, maybe for, if I count my time in the German government and the WMO, I've been around for 15 years in this business, and the last mile problem is not resolved. So we need to think about how we can finally get to the people. We need to share data. Finally, in hydrology, you have seen on the one slide what works for metrology does not work for hydrology, and that's a political awareness thing. And we should also, and this is really something that is related also to yesterday's debate about financing, we should just stop financing partial solutions in the hydrological value chain that will not link to what is before or what comes next in the hydrological value chain. So no more weather radars without a clear definition of what is the service and the benefit of that weather radar. No more hydrological infrastructure if that is not related to actually a service provision for the people that comes from it. And we should also not create lots of services that are based just on, I don't know, global models, because the global models are not validated well enough in those areas where the biggest service need is. This is especially Africa and some parts of Asia. So I think we need to be more strict with ourselves in supporting only those solutions who make a rationale in that value chain context. What is the key? I think the key is addressing the knowledge gap. I don't need to talk much about this here, but this is something that's recurrent also. The key is also to address the lack of political, I want to say now for being more friendly, political awareness. So really we probably need to step up political awareness that an implementation plan for SDG 6 and related issues is needed, and that we need to, in the next years, all work together to create opportunities for countries to engage in such a framework. I think and this is now my personal statement, I also think a lot of the water situation has to do with ignorance, greed, and corruption. And I know that's not PC to say that here, but if somebody in an Asian city or South American or African city pays 1/3 or more of their income just for drinking water, I mean, imagine your salaries and imagine you would have to pay 1/3 only to drink the water that you need in a day. I think that's a shame for humanity. And I think this is not because there's not enough water or nothing. This is because people take advantage of people who are in need. And I think this is, I am ashamed to be part of it, but I think we need to be more clear about really stepping up in terms of the human right to water. Take-home message for me is technology can help to integrate all the different services that we need to provide. But technology alone will not resolve it because of the aforementioned issues, especially about awareness and will. I think more than anything, we need common sense and solidarity, and we can resolve the water crisis if we work more together and less against each other. Thanks a lot.
Thanks, Johannes, very much. I think it's interesting to see also how both our speakers, going towards the conclusion, were mentioning holistic approach on the one side and this idea of a hydrological value chain that you have to cope with the whole chain. Otherwise, it would be difficult to implement technology in any case, in any circumstances. But I would like to move to Joe now, and because I think that your experience, Joe, is particularly important to understand what are the specific challenges that you see for making possible things, making doable things, moving towards implementation. So would you like to maybe start with this?
Certainly. First off, I'd like to thank the Hungarian government for organizing this event. It's an important conversation, I think, as everybody's aware, and it's good that we're moving forward with it. A lot of what I would say has already been said, starting with the first session yesterday where we talked about the need, and the Minister Chaptaris highlighted that again. And he went into the various sectors where there's opportunities, whether it's water recycling, groundwater recharge, and all the various area irrigation where there are opportunities for improvement. I'd also want to highlight that in the second session yesterday, there was a discussion about the value of water. And in that conversation, we started talking about technologies and the opportunities for where do we apply. Is it technologies, or is it the institution of people that is setting the stage? And I think that was important that it came out when we were talking about the value of water. And in the session right before this, we were talking about economics. Again, the conversation went at one point away from economics and started talking about the decisions that people make and whether it's strictly a financial issue or are there other factors that go into it. So I think the conversation seems to have a thread that's going throughout the entire summit, that there are other factors besides just technological solutions or financing, which we have often dominated the conversation in water, that are relevant, and it's encouraging to hear that we're taking those on. When I think of technologies in water, I usually think of it in three areas. First is to reduce demand. But a lot of the technologies that reduce demand aren't in our water sector. I think one of the more notable has been LED lighting, the reduce of electrical consumption. That was, as mentioned in the last session, those subsidies helped push that forward in a very short period of time, and has reduced electrical consumption, therefore reduced the amount of water for hydropower or cooling water for traditional energy plants. Other things that are important that were pushed forward through subsidies in large part was the development of solar panels. And that these are also ways of producing electricity without having to depend on water to make that happen. There are places that are also expanding solar power in conjunction with reservoirs that produce hydropower. Using the same transmission lines, solar panels are being placed on land, and some innovative places put on the water itself, thereby reducing exposure to sunlight and some evaporation loss. And the cooling water acts as a sink to reduce the heat on the solar panels. But it uses the same transmission lines. And this is one way of reducing the fluctuation in flows out of hydropower plants, which is an environmental issue that we have to deal with. We also have leak detection. We use a lot of technologies, and they're available. These are well-tested, resistivity, ground penetrating radar to determine where leaks are. Along with that, meters. Meters are fairly common. You just have to know to use one. When you have water that comes out of supply, and then you go and look at how much water is being used at the distribution point, you have to meter it to know whether there's a difference. But if there's a major difference, you know to go look for a leak. There are some places that have leaks as high as a third of their water. So these are areas of great opportunity. We can increase supply. Reservoir storage continues to go down. It is a natural phenomena that sediment that erodes from in the streams will fill the reservoirs. But we know how to flush reservoirs. There are some environmental considerations. But we also know how to drain reservoirs and excavate the sediment. So we know how to do these things. That's not really the challenge. And then there's aquifer recharge. We're doing more of it. But the idea that we would capture floodwaters in those areas that have floodwaters, I know some don't, but to capture that water and instead of letting the flood areas, but actually work aggressively to recharge our aquifers is a great way to store it. We lose, there's less evaporation. As long as there's no contamination in the groundwater, it's a viable option. And people are starting to move in this direction. Reuse of wastewater, very proven technology, particularly organic loads. And I think we're going to get some discussion of that in a second, about how to reduce the organic load and reuse it for irrigation. And there are places, San Diego, Miami, that use it for drinking water, as well as other places around the world. So we talk about flood risk being, that would be the third bucket that I put these in. We have structural solutions, levees, wing dikes, dams and reservoirs to hold back water. We also can use non-structural solutions like improving wetlands to capture and hold water. But land use, having zoning or restrictions on slash and burn or other types of irrigation processes that or farming processes that increase runoff but decrease infiltration. So the challenge, I guess that's where I'm getting to, and I know you're in a hurry for me to get off the stage, but how do we apply existing and new technologies? That is the real challenge. If I were to look at the technologies that are available, and someone out there will challenge me afterwards, I'm sure, to say, I have an exception. But in general, I'd say our water technologies, if I were to give them a grade of A to F, A's best, F's failing, I'd give most of them a B or a C. I mean, they work. They're redundant. They have the ability. So what's the challenge? I mean, don't get me wrong. I think we should continue research. We should always be trying for the A. There's value in doing that. But the real challenge is, how do we apply them? And both the minister, who mentioned at the end of his talk that technology alone will not solve the problems, and Johannes, you did the same thing in your talk. You mentioned about there are other things that go into this. I would say in a different form, for those who are academic, you think of R&D, research and development. It's the D part where we're struggling. How do we develop it? How do we transition state of the art into state of the practice? And a lot of that gets into education of our technical people, but more importantly, how do we educate the stakeholder, the consumer of the water, the consumer of the resource, and the decision maker? The decision makers may not have a background in hydrology or meteorology. We get that, but we all ought to come from the same perspective, and we need to have a decision approach that allows for everyone to participate in a relatively equal manner and contribute what we need to contribute, and come at it from a issue-based rather than a positional-based bargaining. Too often people know what answer they want or don't want, but not ready to compromise. And how do we start early in the negotiations or the discussions to avoid that situation? I would say in concluding that, yeah, I'm getting to the end here, is funding is a challenge, and we'll never have enough funding. But even with all the funding available, even with the very best of a technology, our real challenge lies in all of us coming together and using what we have to apply the technologies that already exist in a developing or a developed nation to make sure the water that we have is used wisely, and that the water that we have is economically, I already said wisely, but economically used as well. I think I'll stop there.
Okay. Thank you, Joe. Thank you. I got your point. They use what we have. But still, I mean, at least working at the university, I still have an open eye to innovation and, of course, searching for A's, if we do have C's already. So maybe, Istvan, we can now move to your experience. And I know your experience is specifically in the urban environment, which is probably where really huge challenges will converge in the coming years. So, and also your experience goes towards the notion of circularity, which is also a very trendy, if I may, approach that we have in economics these days. So please, could you share your views? Thank you, Istvan.
Thank you very much, Abe.
Excellent.
Okay.
Yes.
So I fully agree that sustainability is not just about implementing new technologies. It's really about changing the attitude and changing the perception of our waste and our way of operation. With this explosive urbanization, I think that our cities have become the biggest parasites of our Earth, allegedly responsible for more than 80% of all the planet's resources, either directly or indirectly in the form of a virtual water footprint, the use of food and agricultural products. So if we want to change this world and make it sustainable, we need to make cities circular. And what I believe is that this urban circularity must be water-based, and a water-based urban recycling system should be implemented. This circularity and water-based urban circularity must be cellular and network-based, just like the internet. So the next question is that how you can provide, create a water recycling which can be combined with energy recovery, with the transformation of organic waste into a metabolic network of a city. Because a circularity sounds nice, but if you imagine that the stuff is coming back and again and again, you need special urban organs which can make this a reality. It means that nobody wants to live close to a traditional wastewater treatment plant. It is typically ugly, in most cases smelly, and you don't want to live and work. And you don't want to have the water coming from that specific plant. So we need a special technology, special solutions, which are not just efficient, but can be fully integrated into an urban environment, aesthetically, culturally, socially, architecturally. And this is one thing what I'm doing. I'm very much involved in designing, building engineered ecosystems using several thousand of species, from microbes up to higher organisms, including plants and protozoans and snails and fish and invertebrates, all densely packed in an extremely small physical and psychological footprint system, which you can very easily can live by. Something which looks like a botanical garden, you can even enter, listen to the birds, and so on and so on. And this is something which can and should replace something like this, not necessarily our solutions, but water recycling systems which can be distributed. A decentralized system can work together very easily with large centralized systems. So this is one thing which I believe as what we need, this kind of water recycling systems which can be implemented in the urban environment. And the second thing is that you can be circular or sustainable in each different subsegments. You can recycle water, you can recycle waste, but just think of our body. We have a circularity system, our blood system, which can deliver to each of our body cells the water, the energy, the food, and can take away the waste, the metabolites, and everything in an integrated infrastructure. And this is something I truly believe we need, that closing the loops of water and energy and waste and food loops, we need an integrated system. Something like a big urban smartphone, an operating system, just like the Windows, the iOS, or the Android, a platform technology, where you can download, you can add different apps, which can be combined depending on the local requirements, the opportunities, the metabolic pathways. And you can change functionality, you can change the capacity, a dynamic system, really very, very similar to what we have built up in just in one generation in the ICT sector. We need the same just now, not just with bytes and kilobytes and bits, but how we can intelligently and efficiently manage tons of water and the megawatts of energy and so on and so on. So this is what I believe we need.
Okay, thank you, Istvan, very much. Yes, you have given a very clear picture of the complexity of the system, in particular in urban areas. I think Giovanni can also help us maybe zoom in to some extent to one specific aspect, feature of this complexity. I know you have worked a lot on water, but also on energy. So would you like maybe to develop a little bit more specifically on this topic, maybe?
Yes, thank you, Carlo, and thanks for the question, because I think it catches one of the key issues for the future, and I want to exploit more what just Istvan said. I think we do need now to change the way we, let's say, develop our policies and our also scientific background for the future sustainable development of the water system. Water should not be developed as a silos per se. Water should be developed together with all the other sectors. So I think we do need to think and to provide scientific support from all the energy, food system, water, ecosystems, because this is the way that the future overall development should be built up. I can give you just a number before we start. And I get from the analysis done by the Joint Research Center of the European Commission on the energy and water nexus. The energy sector withdrawal of water is 74 billion cubic meter per year. Compared with the 50 billion cubic meter of the public water supply, means that the energy per se is already a huge consumer of water. And then you can consider agriculture. So you see that you cannot continue to develop policies or even science for water ignoring the others. And it's not so easy, because when you put together scientists working in different fields and they ask them to use the same reference data or models that they do talk to each other, reference scenarios that are compatible, then you start a completely battle. So this is, however, the clear need for the future, to develop an integrated 360 degrees approach, both from scientific point of view and political point of view. Because otherwise, we will never find a sustainable solution to the real problem in different regions in Europe, which are simply connected by physically. So if you go in the Mediterranean, and you even look forward in the climate change, there will be always more and more stress on the water system. But the water is important for agriculture, so you need to guarantee the food. It's important for human beings, it's important for the energy. So whenever you do find a solution, it should be integrated. So this is why, for example, the Joint Research Center started a project which is called WEF, Water, Energy, Food and Ecosystem, in different locations, so Mediterranean, in Africa, in the Northern Europe, in the Central and East Europe. Because we do need to elaborate sustainable, integrated solutions. And this is very clear in the Green Deal target of the new Commission. So when you go for this kind of overall target for decarbonized energy production, okay, it's very good, because this will mean more or less more modernized let's say, burning, so power plant, but also introduction, of course, of renewable energy, which will diminish the overall water withdrawal. So this is good. However, it becomes even more complex, more flexible. We need to understand how do we couple a flexible, intelligent grids, smart grids with the energy production, with the water availability in each area. For example, you may have in some area that will still be based very much on nuclear power plants or coal plants with or without CCS. Again, these are very water-intensive solutions. Even hydrogen will be very water-intensive solution. So the decarbonization process, which has been now launched in the Europe and will be, I think, will be worldwide, is very positive. But it does put us very clear challenges, how to couple much more decentralized, much more flexible, much more difficult, interconnected system of energy, water, and all the other sectors to find proper solution. For example, you mentioned also desalination and reuse water in agriculture, so wastewater. Of course, it's important, but it means also to have a clear understanding how can we develop a common standard throughout Europe. How can we develop intelligent and energy less intensive solutions? And again, also the desalinization. If it is coupled with photovoltaic, solar energy and storage, it can become an economic viable solution for lots of millions of inhabitants in the South Europe, especially again in the forecast of more and more or higher and higher temperatures, so scarce and more and more scarce water availability. So from a scientific point of view, my request is that the scientific community should go for a very much more integrated approach to this kind of integrated problems. And dealing with water together with energy, as you said, I was also director myself for 9 years of the Energy Directorate in the European Commission. Now, since 3 years, I'm for the environment. So for me, the nexus is very natural. But again, it is mandatory to have this kind of integrated approach towards this kind of integrated solutions, no? And difficult because it's flexible, because each single area or each single region needs different solutions, respect the northern cities and the southern Europe cities, and even in Africa. So this is very much, however, the only way to go. If we still go ahead per silos, water at all costs, energy without considering water withdrawal and without scarcity and other competitors, then we will not ever receive or achieve a sustainable solution for the sustainable development of the society. This is my very first comment.
Okay, thank you very much, Giovanni. A lot of important keywords that I think we are accumulating and telling us, I think, what can be the role of technology for solving our complex problems. But I had a quick chat before with Pierre, and you were mentioning specifically this big question that was touched by Joe also about solutions that maybe we have already from a technological viewpoint. And again, maybe since this issue is so important, I would like to have your opinion concerning, do you think we do have everything we need and therefore we have to search for bottlenecks around us? Or what is your opinion about that?
Thank you for the question. It's not so easy to respond to this question. Firstly, we all agree that we are not on the right track to achieve the SDGs about water sanitation. And that is a very big problem for us. Okay? And this morning we discussed what is missing. It is financial which is missing. We say not completely. It is most complicated. Governance maybe is more important than finance. This afternoon, is it technologies that is missing? That is missing? That is a good question. You know, my company was involved in the previous international commitments, which was MDGs, because out of 8 objectives, there is one about the question of water sanitation, to have the population that have access to water and sanitation. And the UN reports very frequently that with the basic adapted technology, we can reach the commitments. But nobody knows what were this technology basic and adapted, and nobody has considered as a responsibility to put around the table all the professionals, whatever they are, to discuss, do we have this technology? If we don't have this technology, how we can have this technology? Nobody knows that. Okay? That is a problem today. And of course, in this past, in this period of our involvement in international commitments, we say, no, there is not adapted specific technology adapted to connect population. When we have social connection in developing countries, they are social because they are less expensive, but they are not different than the other connection. They are not. It's not a low-cost technology. It is technology with the recovery of the cost is not on the consumers, but it's not a low-cost technology. It's something different now when we work in the rural operators, because of course we were, as I said this morning, we were only urban operator. Now, if we want to be really a partner to deal with expectation of the population, that is the spirit of the SDGs, we must have new cooperation and new alliance with other actors, including those we are working in rural area where we are not there. And of course that we have to adapt it and to define new technology, because you have no energy, you have no common networks, we have to find adapted connection to that. So we have to do that. And for that, the spirit of the SDGs is very interesting. For me, we can't reach the SDG 6 if we don't include the SDG 17 with him, because it is through the cooperation and alliance we can answer to the expectation of the population. That's the first thing. For the solution, because in fact we know the solution to deal with the water crisis. It is to waste less, to polluting less, to reusing more, and to adapt cities and regions to the question of the floods and droughts. We know that, and for a long time we know that, for 10 years maybe. Have we new technology to do that? Yes, maybe we have new. It's sure that the all digital technology help us to have a better understanding of how the networks, and that means that we can limit the leaks on the network through the digital technology, and we can, and maybe it's more important, that I think that the decision maker must have a better understanding how is their own networks. If we have a technology, that means if they have direct lines, they can know where they have the leaks, what is the situation of their own assets. Okay? So I think for that, the digital technology can help us to deal with the big problem we have. It is the lack of the culture of maintenance that is really the very big problem for managing water. About the question of new resources, as I say, of course, we discuss about desalination. Desalination, some years ago we say I think we think that desalination can be a relevant response to deal with the question of the drought and the scarcity. Today is not so easy because it's costly in energy. The question is not, of course, the price of the water system is decreasing, but the cost of energy is important, and the question of ecology is not completely solved today. So it's sure that for us, we consider that the question of the reuse of water is really a relevant answer in all parts of the country, because you have scarcity all in part of the country. The problem is that today the regulation is not adapted to such evident response. As you know, in Europe we have a big discussion with the European Commission about that, and in France you can't have agriculture irrigation by reuse. So a Frenchman can buy tomatoes from Morocco where he was using irrigation, but he can't buy French tomatoes by irrigation, because irrigation is forbidden. It's okay. So you have a problem of regulation. The regulation is not adapted of the question of technology today, and we are not on the same at the same level in the comprehension of the stakes, and for that we have a big problem. Third question about the question of adaptation of cities. What is very interesting, the keynote speaker is not there, but it's very interesting that in a lot of cities we work a lot between hydraulic community and meteorological community, and that is a very good news. And in Copenhagen, Denmark, we work a lot through a European initiative to have a better understanding on what can happen with the floods and the rain water. And we imagine a new technology, very complicated, by we have a better information on what happens for the rain, where it's raining, okay? And with a hydraulic system, we can open or close some reservoir depending on the information we have. And that is very, very low, very cheap investment that we made because we work together. So one of the response is to have open mind to other sectors, to work more together, okay, and to think out of the box. And I said this morning, I am convinced that is a problem for the water community, is to be more open mind what happens in other community and to work more and more together if we want effectively to find technical solutions which are not expensive. We are not revolutionary, but you are adapted to the population. And what is sure is that the population will not wait very, very fast. So it's now we have to have this spirit of open mind and to work more and more together and to find new cooperation and new alliance if we want to reach our commitments.
Mm-hmm. Thank you, Pierre. Quite a stimulating contribution to our discussion. Now we have to manage our time, so we have 17 minutes and 44 seconds. So we can, Giovanni? Oh yes, please. I was going to ask if you want to have a quick reaction to what the other said.
Positive news that the new water reuse regulation is very advanced. So we have now passed the first reading. We have already the trilogue final stage. I'm confident that it will be adopted by the end of this year. So which means we will have finally common requirements, minimum common requirement for the use of water reuse in irrigation or for both food and non-food crops. In agriculture. So finally we will have again the common ground in Europe for reusing this very untapped potential water use in Europe. So this is very important and finally we will have very soon.
Okay, thank you, Giovanni. So now maybe we can go look at the audience and ask the audience if we have questions. And maybe we may still have some time maybe for a final remark from your side. Do we have any, maybe? Yes, I see one down there.
Thank you very much for such wonderful presentations. But the question is technology to avoid water crisis. What is missing? All the speakers almost confessed that there's a lot which is missing. So my question is that as a developing, because I am from Pakistan, which is a developing country, and we have a lot of issues. And most important thing is I think, is the political will. I will give you a very small example. I was tasked to install meters into the very rural area in Pakistan. So I convinced the community. They were even ready to pay, and we started even putting the meters. But there were some protests. And behind those protests were the politicians, because they were their voters. So because they were paying on the flat rates, so if they have the meters, they will certainly. And now, having done that, we know that we were able to save 20% of the saving in the water. Similarly, there are smart meters in Singapore and others. So my question is that we need to work more on the politicians and the availability of the resources, particularly in terms of the finances to the developing countries, then maybe we are able to avoid this crisis. Thank you.
Okay, thank you. Does anybody want to answer? I think this your contribution is very much in line with what we have been saying so far, but do you maybe want to add something or react? Joe, please.
Everyone's looking at me, but I tell students, I do teach a little bit, that the greatest challenges that engineers will face aren't the technical challenges. It's the social, economic, and the political aspects of implementing the technical solutions. The other thing I say is that the best optimized engineering solution is usually the one we don't use because it has to balance out with the other considerations. And that's the reality of life. And it's not a bad thing. So the idea of looking at our individual, I shouldn't say it that way, but looking at a problem or a challenge of water availability. In Pakistan, you have flooding and you have water availability issues. Looking at those from a systems perspective is an important way of looking at finding a sustainable solution. The challenge often is getting the people that are involved to take a broader view of what's required to be involved. Because the question in front of them may have a short-term solution that's more affordable, but yet there's a longer-term solution that for an incremental addition in cost can provide value over the longer period. And I think this is where we have to look at a project delivery team that looks at a problem being composed not of design professionals alone, but composed of economists, city planners, politicians, and providing a solution that is developed in conjunction with everybody's input. One of the things that some of our folks have been involved with recently, or we do quite often, is hydrologic analysis of whether it's for a flood event or a water supply event, and the development of a model, a hydrologic model, but it's a very simple model. In some ways it may be completely an analog, or it might be with a spreadsheet out of Excel. So it's none of the very sophisticated hydrologic programs that exist, but using an understanding of the principles, then you engage the stakeholders and allow them to be part of finding the solutions as the design develops. And this takes time. It takes money to develop it. But if you can put the money up front, sometimes it takes less time to actually deliver the project. Because we have lots of projects where we come to a solution, people don't like it, and we just don't move forward with it.
Oh, yes. Yeah. So. Istvan, you want to add something, please?
If you're looking, we are looking for a very practical solution, we must address the financial aspects. And let me give you an example. With my previous company, I developed a wastewater treatment technology, which was supposed to be one of the best and definitely the sexiest, which could clean wastewater to spring water quality. And I thought that giving back this high-quality water to nature is most sustainable way. And I was wrong, because giving back a valuable material to nature for free, this is stupid. So what I've realized, and moving to the next generation, I realized that really what we need to do is to convert a water infrastructure from a cost item to a profit-generating machine. And this means that we need to implement technologies. Actually, the technologies are ready for this. That for a biomaker, what I call this an urban special organ, which can convert wastewater and different materials into products, into water products, energy products, biologically manufactured products and materials, which can be recycled, reused, sold, and it is then from in a second it will be a no-brainer. That you don't need to find how you can find money for something which will never pay it back.
Nice. Okay, thank you, Istvan. More questions from the audience, maybe? Oh, yes, please.
My name is Henk Holtslag from the Smart Center Group. We heard that there is enough technology, and I fully agree. What we think is missing is awareness of technologies. I give you one example. I was talking to a person in Gambia last week. They make family wells for $150 up to 25 meters deep, including a pump. This is knowledge that is available there, but it is not available in Tanzania. So what we need, we think, is a huge South-South knowledge exchange of a range of technology, not just the high-tech, but also the low-cost technologies. So again, the question, as I had this before, who is going to fund an exchange of technology of these options? Thank you.
Thank you. Does anybody want to, maybe Giovanni?
Just maybe as a partial answer, the knowledge share, the knowledge management, the citizen involvement and the awareness is very clearly felt as one of the key priorities for the Commission in the future, because we understood exactly what we said, that it's not sufficient to have solutions and we have the analysis, but we need also to be in contact, communicate. First of all, to involve all the parties. I think this is a revolution, but this citizen engagement is definitely important. But the awareness is what was missing in the past. And I can tell you that within the European Commission, the Joint Research Center will be in charge for the knowledge management. So we will develop some knowledge center, for example, for water, whereby will be just one entry point for all wanted to get information about what is going on, different projects, results, analysis, technologies in that sector. So we will try to have a much better communication way to all citizen experts, stakeholders, industry, to make a much better coordinated flow of information. So I agree with you, this is very important.
Thank you, Giovanni. More? Yes, please, Ethan. Yeah.
One remark. I think that we are in a very interesting situation, moving to a really circular economy. It has happened that companies, organizations, academia, industry developed apps, solutions, particular solutions in different areas for circularity. But there's one thing which is really missing. It is the organizing principle, the operating system of an urban circularity. Something where you can run your solution. And this is what I believe is happening now, looking for an emerging algorithm which can connect all these individual solutions and can run on a platform. And I think that this can be the biggest thing in the history of urbanization, if we have the operating system of a water-based urban circularity.
Wow. Yeah, it's, my comment is wow. So I mean, yeah, please, but Joe, please go ahead.
Let me add one more thing to that. When we talk about this knowledge transfer, I believe it comes in two components. One component we kind of all visualize. That is the fact that there's a need somewhere and the knowledge needs to reach the people that are involved with it. I think we covered that. The other part is a lot harder, and that is the long-term understanding by people of what the issues are when it comes to disasters or water conservation. I come from a country where most of the population is reasonably well educated. Yet there's a great misunderstanding of the importance of water conservation and the importance of preventive flood activities. And yet we're continually threatened by hurricanes and riverine flooding because people make unwise decisions. It would be one way of saying it. So this idea of the other part, the longer term education, is something that starts with young people. And it's hard because most of our folks that are in charge of these things aren't looking 10 years out and 20 years out. But I think as long as we focus more on the immediate reactive type of knowledge transfer, that's all we'll ever do. So somewhere this idea of what is at stake has to reach people at a younger age. And that, whether that's through your Ministry of Education or Department of Education or whatever, the media, I think that's key to having a sustainable solution.
Yeah, I think you're absolutely right. I mean, this time dimension, I mean, when we talk about sustainability is crucial, and we have to look at younger generation to provide the basis for the long-term future. Otherwise, it's difficult to find really the solutions we are discussing, I think, those that are integrated, that are sustainable, that have a picture of the thing with a long-term perspective. But let's see, we still have a few minutes. If we have another maybe question from the audience, I cannot see. So if you don't have more questions, I would like maybe to use the few seconds we have. If you maybe want to add something, for example, me personally, I would be very curious to know how do you see, so I think we are sharing a rather common vision about the issues of technology, but how do you see your role in the coming future to make an incremental contribution to improve the current situation? I think we have quite different perspective here still, and I don't know if you want to say something about that, how you see what is the mission of Veolia, for example, what is the mission of the European Commission and so on, if you like. Please. Yeah, why not?
For Veolia, is two things. Firstly, of course, we are completely involved with the question of circular economy. And it's very interesting that circular economy will not only focus on the question of waste, it's not to make a resource with the waste. The water has really a real role to play in the circular economy. To put water in the circular economy is very interesting, including the capacity of the water to eat some public assets like a swimming pool and so on, because we can do it, okay? But it's very difficult for our clients, essentially for decision makers, to include the circular economy of water in their mind. So we have a lot of job to do that. The second is really to have a novel approach of the territory. We work at the local level because we manage local resources for local clients. We don't transport nothing, no water, no energy, and no waste. And we have a new approach of the territory, that is to know at the territory what are the producers of resources and what will be the needs of the different actors of resources. And for that reason, the question of the reuse water is very interesting. The reuse water is a new resources coming from the municipalities, but it can be new resources for industrial, for agriculture, and for so that is the new approach, and to have a better understanding at the local level, what are the resources, what are the producers of resources, and to try to meet them. That is a good challenge for the future.
Thank you, Pierre. We still have 1 minute for some very
very simple. The Commission,
thing.
from one side, should continue its own mission for regulation, for new standards. I think it is to put possible harmonized set of standards and regulation throughout Europe. That's for sure. But on the other side, I think we should also stimulate this local initiative, go into the territories. It comes to my mind the water initiative on the smart specialization platform. This is this water smart territories, which means to go in the different territories of Europe, look at their particular peculiarities, so the infrastructure, the different industries they do have, the SME, to stimulate more and more investments to get profit from their synergy. So to go along also the territory, not just to be blocked in Brussels, but also to go and develop sustainable integrated solutions in different territories, stimulating and helping the entities and the reality that are already in the territory.
Okay.
I want to be very, very short. What I really, how I see myself, my role is combining nature's forces with human intelligence, and it needs a really high-tech solutions. And I'm really very proud to work very closely with the European Space Agency. And of course, it's very interesting to know, to see how an engineered ecosystem would work on the Mars. But my perspective is that I truly believe that we have to use a space technology and bring it down to Earth and solve the problems of humans here on Earth, and then we can go to the universe and be happy to
Sure,
go around.
thank you. We are running out of time. You want to add something, Joe? Or?
Very quick, I think we've covered all the main points I had to say. I'll give you a little anecdote to leave with. The Corps of Engineers is a very large engineering and construction organization. And prior to 2005, we did our design for dams and levees based off historical information on probable maximum floods. After 2005, that was Hurricane Katrina, we changed our approach to a more technologically sophisticated risk-based design. And we're very proud of how far we've come. But part of the change for that was not just because it was more technically rigorous and perhaps more accurate, but it also communicates better to the people that are served by it that there is an inherent risk that remains. We call it residual risk. So by technology, you can include all the different things that we've talked about today.
Sure, sure. Okay, thank you all very much. It was very stimulating and interesting for me for sure, but I'm sure also for the audience. So thank you again, and I would like to thank the Hungarian government and our colleagues here in Budapest for being so kind of inviting us and giving us the possibility to meet and to share our experiences. So thanks again, and thank you for attending this session. Thanks.